Hey guys, here we have a more complex problem that would really make you think back into algebra, and this is why it's important to have like your fundamentals pretty much down because you will be using them a lot in this problem. But yeah, feel free to pause the video and solve it. Post your answers down below or your strategies down below. There's many ways to solve this problem. This is probably just one of the ways. But yeah, without further ado, let's get started. And one thing, my voice is kind of wonky today. I'm getting better from a head cold, so if my voice cracks or if it just sounds weird, then I'm so sorry. But yeah, let's get started. So I like to refer to the sodium carbonate and the sodium hydrocarbonate as X and Y. So I'm going to name this X and this is going to be Y. So X will be your sodium carbonate and Y will be your sodium hydrocarbonate. We know that X plus Y, both of those that becomes a mixture that contains 3.80 grams. And we know that we have 48 grams, 0.48 grams of carbon. And we also know that sodium hydrocarbonate is equal to, just by simple math. The next step we're going to do is we're going to, we're going to find the moles of each. And because we don't have the actual values for X and Y yet, we're just going to leave those in and we'll substitute them out or solve for X later. So we know that X equals the grams of that. So we're going to do moles. We're going to change colors. We know that moles of sodium carbonate, we have to have the total mass. So we have the mass of divided by the molar mass, the AMU. So we said that the mass of sodium carbonate would be X, just because that's what we labeled it as. And the total AMU for sodium carbonate is 106 grams. We'll be left with moles. Now to find moles of the sodium hydrocarbonate. We're going to find again the mass. Over the molar mass. And just for simple sake, we can't like really put Y. We're going to want to substitute in something with an X variable just so that we were able to solve for X later. I don't know if I said that earlier, so we're going to use that. So we're going to use 80 minus X over, and the total AMU is 84 grams per mole. So another thing that's worth mentioning, and this is how like you're gonna want to approach this situation, is we know that sodium carbonate has one carbon atom, 1 mole of carbon, and we know it has 1 mole. Sodium hydrocarbonate has 1 mole of carbon. So each have 1 mole of carbon. I'm going to write that down. Each has 1 mole of carbon. So it's safe to say that each of these is 1 mole of carbon, because it should be equal to each other. So 1 mole of the sodium carbonate is equal to 1 mole of carbon. your mole-to-mole ratio will be the same regardless. So, our next step, and I might want to leave that in there, sorry, I just hate writing towards the end of the iPad, but I'm going to leave that in there for us to look back on. So now we're going to set up an algebra problem. We know that the mass of carbon is equal to the total moles of carbon times the AMU, so grams per mole of carbon, right? So now we're just going to plug these in. So the total mass of carbon, which was given to us in the problem, is 0.48 grams. The total moles, which are right here, which I'm going to highlight for us, we're just going to plug these in. So we're going to get X over 106 moles. I'm just going to omit writing the grams just so that we don't confuse each other. And 380 minus X over 84 moles times the AMU, which we are of carbon, which is 12 grams per mole. So we see here how this is going to cancel out. These moles, which are going to add up to each other, are going to cancel out. They're going to be left with grams. We have grams. So we're going to be really left with is what the value of X is. So if we go ahead and solve this whole problem, which is pretty straightforward with algebra, you just, you'll do the whole algebra problem method here and you'll get a pretty large way to do this. Or you can just put this straight into your calculator if you have it. So I already did this, so I'm going to save myself the trouble of doing it. If you really need help in figuring out how to do that, just feel free to come to my office hours. Be no problem. So we're going to get X equals 2.12 grams. So we know that X equals sodium carbonate. So now we're going to get the value of Y, which we said earlier was 3.80 grams minus X. Y equals 380 minus 2.2. We get 1.68, I believe. I want to double check that. Just my memory. Yeah, sorry, I have my notes from solving this earlier. Yeah, and then, so we know that's going to be our grams of the sodium. And in the books, it gives you in milligrams. If you want to get to milligrams, you're just going to go 1.68 grams times 1 gram equals 1,000 milligrams. So we would just divide 1.68 divided by 1,000. That would give us 0.00168 milligrams. But I would just leave this in. Grams. It's no problem, really. But yeah, if you guys have any questions, feel free to come to my office hours. Again, like I said, there's multiple ways to solve this problem. Whatever way works for you is perfectly fine and will be graded as equally as everybody else's. This is just the way that I would have solved this coming into it. But yeah, without further ado, thank you for watching and go Frogs!